Now that we see how we can relate the mass of a compound or element to the number of particles, that's going to come in handy when we're talking about chemical reactions. If we want to be able to say how much of a reactant that we need to use to get a certain amount of product, we're going to need to keep track of the numbers of molecules. And so this equation, this simple reaction, these numbers in purple in front are the coefficients. And the coefficients tell us the ratios at which they react. 1 molecule of N2 combines with 3 molecules of H2. And so from that, we could kind of figure out how many molecules of each of these we need if we want a certain number of molecules of our ammonia, which is NH3. And the ratios are important, right? If we had extra, like if we had 4 molecules of hydrogen, it wouldn't matter. Only 3 would react if we had one molecule of nitrogen. Anyway, so look at how I'm using these coefficients down here. 1 molecule of N2 and 3 molecules of H2. What would we get? Well, I can use the coefficients basically right off to say I'm going to get 2 molecules of NH3. And then I could go a little further. What if I had 2 molecules of H2 and 6 of N2 and 6 of H2? We can see the ratio is still right. It's still a 2 to 6 is the same thing as 1 to 3. And so it's like doubling the recipe. I'm going to get 4 molecules. Okay, and then I've really more than doubled the recipe. If you notice, I'm using Avogadro's number here. If I had this many of the nitrogens, then I would have, it's basically a 1 to 3, so 3 times that many of the hydrogens. So I would end up getting molecules of NH3. Anyway, the whole reason that we did that one was to say that this is basically a mole ratio. In other words, for every 1 mole of nitrogen and 3 moles of hydrogen, I can get 2 moles of NH3. So the whole thing about this is that this gives us a way to use these coefficients in terms of number of moles. So we're about to start stoichiometry. Stoichiometry is all of the calculations that you do that relate the amounts. And all of these calculations involve coefficients. So when you do, you're not doing stoichiometry if you're not using coefficients, is what I'm trying to say. And of course, these are the coefficients in front because those are the things that tell us how they relate. So we could, let me erase this, we could read those in terms of, we had been reading them in terms of number of molecules. That is the ratio they represent. But now we see we could also read those in terms of moles. And that's how we usually do in chemistry. In other words, in chemistry, I would normally say 1 mole of nitrogen combines with 3 moles of hydrogen, and so forth. But do not read them in terms of masses. In other words, I cannot say that a gram of nitrogen combines with 3 grams of hydrogen. That is not true because it is a particle-to-particle ratio. And because the molecules are different sizes, that doesn't work. So stoichiometry is basically done by conversion factors. We have one conversion factor already, and so this is my hypothetical reaction. And when you do stoichiometry, you could be like starting with the amount of A and trying to figure out how much C is made, or you could be starting with the amount of A and figuring out how much B you need. It could be between any 2 of these. For now, we'll just look at 2. But anyway, so we have a conversion factor between grams and moles of A, the same compound, and we would use the molar mass of A. And the same thing for any other substance. I could use the molar mass of B here. But now we have a new conversion factor between the relationship between the amount of A and B, and that is the coefficients.